Hey everyone, welcome to part 7 of our Azure Masterclass. This is all about virtual machines and virtual machine scale sets, looking at the core attributes of virtual machines, our options, and then really building on that for things like virtual machine scale sets. As always, if this is useful, please go ahead and give it a like, subscribe, comment, and share, and hit that notify so you'll know when I post the next set of videos. Okay, so virtual machines. And actually, before I go into that, I did want to stress a point. A few people mailed me, hey, is there a handout? Where are the materials? If you actually go and look at the YouTube where this is, if you look at the playlist and below every single video, I actually have a link to the GitHub repository in the comments. So if you actually go to the GitHub repository, if you look, there's a folder for every single one of the modules. In that folder, for example, it will have any artifacts like sample scripts. It will have a PDF of the handout, and it will have the image of the whiteboard. On that main page of the GitHub repository, I actually have kind of the README, and I have all the extra links to extra videos that would supplement the module that goes into more detail about any particular aspect. And so if you want the information, please go ahead and check out the GitHub repo that really has all of the information that I cover as part of the class. Okay, so virtual machine basics. Virtual machines, i.e. infrastructure as a service, is the building block of many services in Azure, and by extension, virtual machine scale sets. It's really useful to understand the virtual machines because even if we're using app services, maybe, it still uses VMs underneath. Often we still pick, well, what's the series? What's the size? What are the various attributes we want to use? So understanding the building block really helps us use the all-up service. It's often the easiest to relate to as it does closely align with kind of what we're used to on premises. So once again, with a virtual machine, we have full access to everything inside the virtual machine's operating system. In kind of the foundational class, I went through layers, and you can really think about, well, yes, there's things like the storage, there's the network, there's the compute, i.e. the servers, and then there's the hypervisor, i.e. Hyper-V. And all of that stuff, that's Azure's responsibility. We don't see that. But then with a virtual machine, we do see the operating system, any runtimes, any middlewares, any apps, and of course our data. So we are responsible for all of those things. We have full access, be it Windows or Linux. I can RDP, I can SSH, I can WinRM, but we are responsible for all those things. So with the operating system, I'm thinking things like patching. I'm responsible for that. Things like anti-malware, I'm responsible for that. Backup, I'm responsible. Maybe there's replication, I'm responsible for that. Configuration, inventory, the list kind of goes on. I'm responsible for all of those things. Now there's things that help me in Azure, there's extensions, there's services, but that's where the responsibility kind of flips over from Azure. So I'm going to think about this is Azure's responsibility. I don't see this stuff. I just get services offered that are built on those. And then everything at the OS or above, well, that's you as the customer. These are my responsibilities. But again, Azure helps. There are things that help me do these things. But essentially, I have full access to the OS and everything above it. So with that said, because I have all that responsibility, I need to plan ahead into, well, how am I going to handle my backup? What is my disaster recovery?
What are the policies of my company? Is it going to integrate with Active Directory? This is a VM. At this point, just like a regular, for example, Windows, it can join an AD domain. I might have existing agents, things like SCCM or SCOM or Splunk or whatever that might be. It's just an operating system. It's just that it happens to be running in Azure. It's essentially a VM. So I can still use all that existing expertise I have. So let's start with kind of the most fundamental element of a virtual machine. That's really the series and the size. Often different workloads have different resource requirements. I have some workloads that are very memory intensive, some that are very compute intensive, some that need lots of IOPS, some that's very network heavy, some need specialized hardware. High performance compute, I need RDMA network adapters between them. Maybe I need FPGAs, I need NVIDIA CUDA cards for AI and graphics for visualizations. I might need access to super fast local storage. There's a whole set of different requirements and focuses we have for our workloads. So step one is I need to understand that. I need to understand what is the requirement I have. Because just like t-shirts, I have different fits of t-shirt. I have kind of relaxed fit, I have sports t-shirts, and they come in all these different sizes. So I can think about VMs are the same. They come in sizes within a particular style, but there are different styles, different series that focus on different things. Is it compute? Is it network? Is it storage, etc.? So we have these different types of capabilities to help meet my requirements. So there are a whole bunch of different series in terms of really what is the focus for those resource ratios. And I want to kind of just quickly kind of talk about really how that boils down. Firstly, we have to think about there's a physical host. So I have some physical host that is going to host my virtual machines. Now, these hosts are deployed in Azure in stamps, in clusters that are all identical. And there's different types of cluster based on the different types of virtual machines it will actually be running. But at this host level, I can think about, well, it has a certain number of CPUs of a certain version. It has a certain amount of memory. It has a certain amount of storage. Now, when I think about storage, there's a certain amount of local storage actually on that host. So I can think about, well, it has some local storage here, but additionally, it has a certain amount of kind of connectivity. It has a certain bandwidth to support a certain amount of remote storage. Then, of course, it has a certain amount of network connectivity, and then other. It may again have special types of maybe Mellanox network cards for big high performance compute. Could have those CUDA cards for visualization, for AI, cognitive services. But I have a certain set of capability of the host. And then we think about, okay, we create a VM. And essentially that VM is going to get placed on a particular host that has capacity. And those same dimensions we thought about for the host really apply when thinking about the VM as well. So that VM, well, it has a certain kind of CPU specification. We talk about virtual CPUs. For physical CPUs, talk about cores and hyperthreading, which really maps kind of logical processors. Then we have virtual CPU. So we think about, well, we have this virtual CPU, which has a number of different attributes to it as well. I can think about, well, I have a certain number of these. I have a certain number, 2, 4, 6, 8, whatever that might be. Then I can also think about, well, I have a certain type. Is it Intel? Is it AMD? Then we have kind of characteristics around performance. So if I think about the performance, the way this is measured in Azure is something called Azure Compute Units, ACUs. And we'll talk about this in a second. This is how I can measure the relative performance of different virtual CPUs for different series of virtual machines.
Also, some of them have kind of boost capabilities.
Additionally, maybe they have certain types of feature.
So what do I mean by features?
Well, I can think about maybe it supports hyperthreading. That is exposed for some of the virtual CPUs based on what the physical is.
Some of them support hardware-assisted
Virtualization. That would mean I can actually run a hypervisor like Hyper-V actually in the virtual machine itself. It's not really recommended. If I run a hypervisor inside the virtual machine, I then lose the benefit of things like Azure Resource Manager, a lot of the Azure capabilities, because now we can't see the VMs in the Azure VM. So we lose a lot of capabilities. We try and stay away from that. In addition to other kinds of features, there's things like SGX, the software kind of guard extensions that gives me that secure capability. And there's other things as well. But essentially, we have different features of the processor. Also, the physical processors of the box, there are newer ones over time. And so what we'll often see is kind of this version. We might see, hey, a V2 crops up, then a V3, then a V4. And that's exposed to us. We can see, for example, hey, there's a DV2, there's a DV3, there's a DV4. And you may wonder, well, why bother? Why not just, I'll take whatever there is. Why do I care? Because generally, as the versions go up, the performance will improve. And the ACU will actually get better. Now, again, you might say, well, so what? Sometimes I get better performance. That would actually be a problem when you're planning. If you, for example, were architecting your solution and you work it out, and on one day you deploy and you happen to deploy a host that's running the latest processor, you get a certain performance. Then tomorrow when you deploy, you happen to get put on an old one and you get half the performance. That would be very, very difficult. So this enables you to be very specific and say, hey, I've already got 4 V2s, I want another 2 V2s. I want the consistent performance. I don't want this variability, because maybe the way I'm balancing, I'm just round robin or I'm doing an equal spread. So I get a very inconsistent utilization. So the reason the versions are there is sometimes it's different features might be exposed. Sometimes it's just, hey, they have a different performance and I want to kind of know about that.
Then they're going to have a certain amount of memory. So that's going to take a proportion of this. So it's going to be some amount in kind of gigabytes. Then there's going to be a certain amount of storage. Now, this can be many, many different elements. I can think about, well, there's a certain amount of local storage for pretty much all of the types. Some of them don't have it, but there's kind of, well, what is the type? For example, is it hard disk drive? Is it SSD? Some of them also have kind of NVMe type storage. So this is where, hey, yeah, this host has some local storage. What we're actually going to do is map to a VHD often within there, for example, for the scratch drive. So I would actually see that. So I would see the type. I would see things like the capacity, how much of that local drive do I actually get. And also there are kind of options around, well, what is the performance? What is kind of the write, what is the latency? So there are some different performance aspect, and that comes into kind of, well, what is the type of that local storage? Maybe some other tweaks around that. So I might get different latency for that kind of local storage, etc. Then there's remote. So hey, I can use remote storage. And here I'm focused on kind of disks, because obviously there's other types of storage service in Azure. There's Azure Storage Accounts, there's blobs, there's Azure Files. Well, that's accessed by the network component of the VM, not its storage connectivity. So for remote, I can talk about, well, how many disks am I actually going to connect to? What is the max kind of perf? Because for a VM, I actually have a maximum number of IOPS and kind of a throughput.
And that's important to understand because I might just keep attaching disks to a virtual machine, but the VM has its own limits. I can't exceed those. Now, sometimes I have a boost capability. And what that boost, actually not boost, we say burst. Burst is a better word for that. We have a burst capability. So sure, I have a normal amount of maximum IOPS and throughput, but for a limited amount of time, I can actually burst up to a higher IOPS, a higher throughput for that to give me a better performance. So I have kind of these remote storage capabilities. Then, of course, well, we have things like network. And once again, for network, it can be like, well, how many NICs? What is my kind of throughput? What do I actually support on there? So I can think about like bandwidth. Actually, I'm going to write bandwidth is a better word for this. So I got my NICs. It's terrible today. So I've kind of my number of NICs. And I can think about what is my bandwidth. And this is where if I'm using things like Azure Storage or SMB or NFS, that's going to take my network path of my virtual machine. And then there's just kind of special stuff. I can think about, well, maybe I have these NVIDIA CUDA cards. Maybe I have these big high performance compute and I'm using RDMA networking. Maybe I have these kind of big NVMe type capabilities. So I have this massive amount of super high performance, super low latency cache. So you have all these different dimensions of the virtual machine. And this is where the series and the size comes into play. Because we have all these different series. If I kind of shove that over for a second. So we can often think about things like a general purpose. So a general purpose has a good kind of balance. Typical ratios of CPU to memory, and there's things like the B series, the D series. I'm going to forget all these, DV3, V4. So there's different versions as the processors have improved. There's the A series. Most people don't touch the A series anymore. A series is kind of unique. When I talk about this local storage, the A series uses hard disk drives. Everyone else, it's an SSD. So generally, we stay away from the A series these days. Then I can think about ones that are compute optimized. So the ones that are compute optimized, well, they have a greater ratio of CPU to memory, for example, the F series. Then I can think about ones that are memory optimized. Now these might be very good, for example, if I had maybe a database, for example. So things like the various E series, the M series, the DV2, they have a greater ratio of memory to CPU. The ones that are storage optimized. So when I think about storage optimized, well, it's the L series. The L series, it has things like big throughput for the VM, but it also has those kind of NVMe, super high performance local. Now it's ephemeral. Ephemeral, if it's in the host, it means it's ephemeral. I.e., if the VM is deprovisioned or it crashes, I'm going to lose the content. So the way we would typically use those kind of NVMe storage is when it starts up, it would populate it with stuff like a cache and use it from there. So maybe I need some kind of cache that doesn't have to be durable. If I lose it, hey, the actual data is persisted somewhere else. But I can get this very high performance local kind of cache. Then there are, for example, the GPUs. This would be kind of the N. And there's a whole bunch of different N's. I think there's an NC for compute. There's a V for kind of visualization. And I think there's a D for deep learning. So those slightly different kind of combinations based on what we want there. And there's high performance compute. So the high performance compute have those kind of Mellanox, so it's a HPC, and that's the H series. And with all of these, there's different like variants, there's different versions. There might be Often you'll see an S variant. The S variant means it can use premium storage. There are other types of variant in there as well. But essentially, that's what the series are based on. Different focal points based on what the workload's going to be. And then within the series, we have sizes, where all of the different aspects proportionally go up within that series kind of set of ratios. So that's the whole point behind it. If we actually look, so we'll jump over and actually take a look at these in a bit of detail. So this is showing me all of the different virtual machine sizes. And again, it's showing all those general purpose, kind of that balanced CPU to memory ratios. It's showing me the ideas between those compute optimized, memory optimized, storage optimized, ones with GPUs, and the high performance compute. So all these different types available. And then the point is, if we go and look at some of these, actually we look at the memory optimized, a bit more interesting. For any of these, we'll actually see there's a whole set of different sizes. Notice here, and for all of them, there are ones with an S, the one without an S. This is about, well, can I use premium storage or not? So here we look at the EV3 and the ESV3. And here's where we see all the different sizes. So we can absolutely work out, okay, we can see this kind of size column here. And you can see the CPU goes up, the memory goes up, the temporary storage goes up, the max data disks go up, the temporary storage performance goes up, the NICs and the bandwidth go up. And they go up proportionally, because essentially what's happening is you're taking up more and more of the underlying host, so you get that percentage worth of the underlying host's actual resources. And for all of these, you're getting kind of the full set of resources. I get all of that CPU. I pay based on the virtual machine. I'm not getting kind of a discount if it only runs at 10% CPU. Unless I look at the B series. So the B series is burstable for the compute. And the way this really works is, you'll notice I get a virtual CPU, but we get this additional base CPU perf of the VM. Now this is based on a single CPU, which is why it goes like 200%, because here we can see it's got 12 CPUs. So I get 200% of what would be one CPU. So essentially it's almost like a sixth of a CPU per virtual CPU I see in that virtual machine. And then you'll notice there's a max CPU performance next to it. So what I can essentially do is here, well, you can see I can actually go to 2000% when it has 20 virtual CPUs. So I can actually burst to 100% of all 20 for a period of time. And what really this is doing is it's like a cell phone plan. The idea being that for that CPU, instead of having 100% of the CPU and paying for 100% of the CPU all the time, you can kind of think about per CPU, I get a certain percent. So if there's 0 and 100, maybe what's allocated to my virtual machine is 10%. So that's what I'm allowed to use. Now, if I'm actually only hovering around 1% here, what we actually do is we start with a bucket of credits, but we actually start accruing more credit. So I'm actually accruing credits. I can actually go well beyond 100, but let's just withdraw up here. So I accrue credit. And then something happens. Well, assuming I've accrued credit, I can actually burst up to 100% for a period of time. And then I'll drop back down. And so when I'm bursting up, you can imagine what they are. Well, I'll start consuming my credits. And then when I go down again, I'll start accruing them again. So if I had some workload that's more variable, maybe it's a domain controllers, they have a burst at certain times, some kind of website that gets a burst of traffic, the B series can be super useful there because it's cheaper. I'm only getting ordinarily a certain percentage of the CPU, but hey, I can go and burst up as required, assuming I have accrued enough credits. So the B series is really kind of unique there, For all of the other VM SKUs, I'm really just paying for the CPU all the time. There's no overcommit. I get that virtual CPU's allotment of Azure compute units. If I don't use them, I'm still paying for it. There's no kind of variation in that. So this is kind of the B series is very unique in that it gives me that ability to burst up and save some money by buying kind of a cheaper VM. Now, as I talked about, within the series, there are sizes. It goes up proportionally, all the different elements based on its focus. Now, some virtual machines actually have a CPU constrained option. Now, you might wonder, what's this all about? So if you think about it for a second, we have all these different SKUs of virtual machine, and maybe there's memory optimized, and there's some, obviously, there's even bigger ones. There's things like the G series, I've missed them out there somewhere, the Godzilla, the M series. And they have lots of memory, but they still have a lot of processors. But if I have some workload where I pay kind of on a compute core basis, like Oracle or SQL Server, maybe it's so memory optimized, I need a massive amount of memory, but I really don't need the associated cores that come with it, even for things like those memory constrained. So let's take a step back. Let's look at these memory optimized for a second. And we can see, let's look at some of these big ones, the M series, for example. Well, on this M series, it's great. I have more memory than kind of CPUs. It's giving me those ratios, but it's still a lot of virtual CPUs. If I want to get to, for example, a terabyte of memory, I have 64 virtual CPUs there. That means I'm paying for all of those CPUs for my Oracle, for my SQL. So what's available are these constrained virtual CPUs. So I still pay for the regular size, but it's essentially going to hide cores from me. So here we can see those same M series, and we can see here, for example, hey, it's the same as an M64, but it's only going to expose 32 virtual CPUs to me. So if I need the memory, but I do not want all of the virtual CPUs associated with it, I can actually hide them. I have that ability to say, yeah, I need everything else, the IOPS, the throughput, the storage capacity, the memory, but I really don't need all of those virtual CPUs. And it's not even I don't need them, I don't want to see them, because then I have to license them as part of my software. So those constrained options are really useful when I have those more strict requirements about having to license every CPU that's inside that virtual machine. So constrained hides a bunch from me. So I talked about the Azure Compute Unit, and this is essentially how we can measure really what our overall performance is. So let's kind of look at this document in a bit of detail. We start off with the A series, the first virtual machine. And in the A series, the good old A series, it was essentially a score of 100 per virtual CPU. All of the other scores are then proportionally to that. So I could see, for example, well, the DV2 over here, well, it's 210 to 250, so it's at least double the performance. Now, the reason it's kind of a 2 number, it's variable, is this little asterisk is saying it probably supports the Intel Hyper Turbo technology. So here we go. ACU uses the Intel Turbo technology to increase performance for a period of time. Likewise, there's an equivalent technology on AMD. So what we're seeing here is, okay, I can see proportionally the performance. Now, if we keep going, we see, well, that's weird. The DV3 actually dropped. So the DV3's performance is lower than the DV2. Like, what terrible batch of processors did they possibly buy to make it lower? And it's because you have to look at this other column. What this is showing you is the DV3 introduced the concept of hyperthreading. So now each virtual CPU is essentially now mapping to hyperthreads, where the physical processor has 2 threads. It doesn't double performance, but I get an increase in performance. So the DV3 proportionally adjusts the cost based on that. So each virtual CPU is slightly lower in performance, but I get double of them. So that's why we see that. But then again, it goes back up with the V4. But this is where I can go and see what is my actual performance of those processors. Here, the H series goes up to 300, the HC, I think that's the King 315. I think that's kind of as good as it gets right now. So that's kind of the highest performance, which makes sense because the H is the high performance compute. One thing I do want to stress is there is no core pinning with Azure. If I think again that the VM has kind of virtual CPUs, the physical box has CPUs, it's not permanently pinned. That virtual CPU is not always this particular physical core underneath. It's Hyper-V. The hypervisor is constantly working out where do I run this particular instruction. Now it understands NUMA, the idea that there's banks of memory attached to certain physical processors, so we'll keep it within there. But outside of that, it's not always pinned to the same physical processor. But that's the hypervisor's job. Hypervisor's job is to do that scheduling, working out. But the ACU is reserved for me. It may not be an entire processor. If you think about some of the smaller VMs and physical processors improve over time, my ACU of 160 may only be half of a physical processor. So I don't necessarily get the whole processor, but the way they work out capacity is they don't overcommit in terms of those ACUs. There's always enough physical processor capacity to handle the ACU values of the VMs associated to it. So the B series, if I'm burstable, there's spare capacity, but it's not guaranteed I could always just burst up whenever I wanted to. Okay, so the VM building blocks. So in the Azure Resource Manager, there is way more than just the virtual machine. So obviously there is the virtual machine. We have the VM, and essentially the VM, we say it's a certain series and it's a certain size. But even within there, not every VM is available in every single region. If you actually go and look at kind of like the Azure regions and by service, you can actually go and see all the different services and work out, well, where is this particular series available? Especially some of the more exotic ones, some of the N, the H series, the M, they may not be in every single region. So you have to go and work out, well, which region is this in? And then even if it's within a region, it doesn't mean it's available in every single physical data center, every cluster. And why that's important is if you think about capabilities like proximity placement groups. A proximity placement group, if you remember, is all about the idea that, hey, yes, within I have a certain region. Within that region, there's kind of multiple physical facilities, for example, availability zones. And then a proximity placement group is, hey, I want to get things as close as possible. So I create a proximity placement group. And that pins it to wherever the first VM goes. And that's important. The point of the proximity placement group is it's bringing things in within a certain very small latency window. So if the first VM I create in a proximity placement group is some generic D series, I'm going to get put maybe in a certain set of clusters that support the D series, but don't support the N or the M, these exotic ones. So I want to make sure my proximity placement group gets pinned to a set of clusters that support that exotic fancy VM I know I want to use. So the first VM you create in a proximity placement group should be the biggest, the most exotic. So if I'm going to use an N series, I'll create that first, or my G or my M. Then I can go and add the D series, the E, whatever the others are. It doesn't matter as much. But make sure your proximity placement group gets pinned to parts of the region and the data centers that support those fancy VMs you want to use later on. Now, additionally, we have this thing called Spot. And if we think back to those regions, they have banks and banks of servers. Within those servers, there's a whole set of capacity. And they're not full. Azure makes sure there's a certain amount of spare capacity for things happen, things fail, you have to spin things up, fail over, etc. But at the same time, you don't really want things sitting there just completely idle. What would be great if you could have some stuff running that if you need the capacity back, I can kick the other stuff off. It's less important. And that's exactly what Spot is. So with Spot, it's basically the ability for me as the customer to get compute capacity really cheap. But it's really cheap because at a moment's notice, I think it's 30 seconds, something like that, if Azure needs that capacity back because a full paying customer wants it, they can kick me out. Now, that's fine. If I have some kind of interruptible workload, it's maybe rendering, it's some kind of batch job that I need to get done, but I'm not in a huge time crunch. I'd like to do it as cheaply as possible. Spot is phenomenal for this. And one of the nice things they've recently done is if actually we go and take a look, let's close these down. When I actually go and create a virtual machine now, I can go and look at the history of the Spot. I can see the price of Spot in regions around me, and what's the chance they're actually going to kick me out. So in here, I'm going to go and look at my virtual machines, and we'll just say, hey, we're going to create a virtual machine. When it comes back, there we go. So we'll say add a virtual machine. And if I scroll down, I can see this Azure Spot instance, and I've got it set to no. And this is where I would just pick the regular size. It shows me how much it is a month. I could go and see all the sizes that are available in this region. So I have West US. I could see everything that I could see in West US. And it's kind of showing me all of those there. But here I can say, well, I'm going to use Azure Spot. If I select this, now I have a choice. I can say, hey, just capacity only. And what I mean is I'll get it as cheap as I can, but they can kick me out if someone else needs it more. Or I can say, I'm only willing to pay up to a certain amount. And I can actually say, well, should they just stop and deallocate it, i.e. stop paying, or actually delete everything associated with the virtual machine. So here we can see normally this D2 is a certain price per hour. So let's look at the view pricing history. And now I can see, well, okay, I've stood the region I selected. This is kind of the price currently for this Spot price. West US is a different price. Central, West Central is actually cheaper. But I can also see the eviction rate. So I can see here, there's only a 0 to 5% chance I'm going to get evicted. Whereas West Central, there's a 5 to 10. West US 2 is a 15 to 20. So I kind of like this idea of West US, 0 to 5% eviction chance. But the price will go up depending on what else other people are doing. So I can put in a price here of what I'm willing to pay. So I might say, well, I'm willing to pay, I don't know what the normal price of this is, 30 cents an hour. And I could say, okay. Once again, if I turn off the Spot pricing, let's say no. So normally it's 85 a month, so you'd have to kind of go and back work out what the normal hourly price is. But essentially I'm getting it for cheaper. The whole point of this Spot pricing is, hey, I've got something that's not in a super rush. I just need to get the thing done. Well, this is a nice option for that. Then we have NICs. So we have network interface cards. So if we start building out a view of what is our virtual machine, we can think about, okay, yes, I have the VM. And that VM is a certain series and a certain size. Then I attach to it one or more NICs. Now the number of NICs depends on the series and the size. Within the NIC, there are IP configurations. And I can have multiple IP configurations. There's a private IP, and then optionally, I might have kind of a public IP. And then that NIC, well, it goes and attaches to, I can think about, I have a virtual network, and that's made up of various subnets. So maybe that's subnet 3, and there's subnet 2, and a subnet 1. I could have another NIC maybe it's some kind of network virtual appliance. Well, it could attach to a different subnet, but it has to be in the same virtual network. I cannot span virtual networks. And these are all within the same region. So I cannot have a VM in one region connecting from a network attachment perspective to a network in a different region. Doesn't mean I can't talk to things in another region. Absolutely, this virtual network might have global VNet peering to another VNet and then via IP. Sure, I can talk to the stuff. But my actual network interface cards, they have to talk to a subnet in a VNet in the same region. And if I have multiple NICs, they have to talk to subnets in the same virtual network. I can't span them. Now at this point though, this is just a regular IP configuration. It's a virtual machine. There's a guest OS. So there's this OS series and there's an operating system running in that thing. Well, now the OS has an IP address. To these IP addresses, if I'm connected to this network, I could RDP to that thing. I could SSH. I could go to web services. It's just a regular network configuration at this point. I can do anything I would do with a regular network configuration. Now, remember, there might also be things like an OS firewall. So just like you would on a regular operating system, before I can get to it, I might need to open up exceptions in that network firewall that's running inside the VM. Exactly the same way, I might have network security groups, which we talked about in the networking module of the masterclass. They might be protecting traffic that can get to that subnet as well. So I have to think about the different layers of security to make sure the traffic is going to flow as I actually intend it to. And then additionally, there's other types of components. There's things like load balancers. I might have some kind of load balancer in here. And I can think about, well, I have kind of a front end, and these networks can actually be added as part of kind of my backend set. So they can be part of a load balancer app gateway backend set to get traffic as it comes in to the service. So I have my networking constructs of this. Then I have an OS disk. Now, ordinarily, it's going to be a managed disk. We want to use managed disk. There is unmanaged storage as well. Again, we talked about that in the storage module. That's where it's a page blob. I have to worry about the IOPS per storage account. It's not a first-party ARM resource. I just lose a lot of capability. So you want to use a managed disk. And that's going to go and be connected to the virtual machine. So I can think about, great, I have over here, I'll do a different color, a managed disk. That is an Azure resource. Now, behind the scenes, absolutely, that's sitting in kind of an Azure storage account. There's a storage account there hosting it. I just don't see it. And that is connected to the virtual machine for the OS. So this is durable. There's at least 3 copies. There are 3 copies of this thing. Now there is the option to have ephemeral OS disks. Ephemeral means, remember, this VM is running on a host. If we go back, we think about here, and that host has some local storage. In addition to kind of that, it also has kind of a cache that it can use for certain things to speed up performance. So ephemeral disks actually can use the cache and even now that temporary storage to store OS disks. This is very useful for virtual machine scale sets. If I have some workload that has no state, nothing I really care about long term, instead of using a managed disk for the OS that takes a little bit longer to spin up, the latency is going to be longer. So obviously that a managed disk is not local to the node, so I'm going to get an increased latency. If there's no state I care about, it's a complete cattle, it's a tin soldier. If it falls over, I'll just put another one in its place. Some of the VMs support ephemeral for the OS. So I'll actually use the cache, and if there's not enough cache, they now also support letting me use my temp storage. And I will actually put my OS drive there. Obviously, if something happens to the node, I deprovision it, I lose the state. I lose everything. I have to just recreate it from scratch again. But they will provision faster, and they will have a lower latency. So if I have a stateless workload, it's actually a good solution to leverage that. So if I have virtual machine scale sets, perfect for that scenario. Then normally, I have a temp drive. There are now some virtual machines that don't. There are now, I think it's the V4 of the D and the E. There's a DD that does have temporary storage, and then there's just a without the D that doesn't have temporary storage. But nearly all of them do. And what I actually have here is I think about, well, remember, this thing again is running on an actual host. So there's an actual physical box running this. So this is my host. It has kind of, remember, that local storage of its own, and it attaches basically a VHD on here for temp. And again, we talked about that in detail in the storage module. Both Linux and Windows will see kind of this scratch drive. But again, it's not durable. If the node crashed, if I deprovision my VM and then restart it again, I'll lose the content of that. There's a big data loss warning on that disk. So if we quickly jump over, and if I look at Explorer, so this is a virtual machine. And we can see here, I actually have this temporary storage drive, D. It has a file on it, data loss warning readme. I can look at this. This is a temporary disk. Any data stored on this drive is subject to loss. I mean, it's trying to tell you as clearly as it can, don't put stuff on this you care about. Windows sticks the page file on it. By default, it's just hidden. If you needed like a scratch drive, it's great. It's high performance, it's local, definitely use it for that. But this is not a data drive. Do not put stuff on this you actually care about. And we'll come back and use this again a little bit later on. So we have that temporary drive as well. And then just basically, well, I can add additional data drives. And these can be of different types. Again, depending on the type of the virtual machine. If it's like that S, I can use Premium. And there's also Ultra. And once again, it's just more managed disks. Once again, they're in their own storage accounts, or maybe it's just hidden from me. But I can have other managed disks. I can have multiple of these. The number depends on the series and the size of the VM. And I can just add those as data. So E, F. I can use D if I need to for the temp. It involves kind of moving the page file temporarily to the OS drive, rebooting, changing the driver of that, but it can be done. Now for both the OS and the data, I can control the caching configuration. So by default, the OS is always read-write, which generally we want for an operating system. For data though, there are sometimes we don't want any caching. I want it to go straight through to the disk. So we can configure this. So if we just come out of this for a second. So if I go and look at an existing kind of virtual machine, doesn't really matter what one. If I look at my disks, so I can hot add. I can actually add additional disks while it's running. Hot add remove. But we can see here, my host caching is none. This is my domain controller. This is where the Active Directory database is. I do not want caching on this, so I have it set to none. But you do have options. Likewise for the OS, I've got it set to read write, but again, you can change that caching option. So understand what your workload is, understand what the right caching option is, and then tweak that configuration based on what you need. Then there's extensions. So extensions where we really start to come into all of the power of Azure helping me. Yes, I'm responsible for it, but there are a ton of kind of extensions that I can add here. Now there's always kind of an Azure agent that runs inside. Be it Windows or Linux, there's an Azure agent there. This helps do some of those core things. But there are extensions around things like anti-malware, there's extensions for backup, there's extensions for config, there are things for kind of replication, so I can easily replicate it to another region. You name it, there's probably an extension there to do it. So once again, if we quickly just go and look at this virtual machine, we can actually jump over and look at our extensions. So you can see here, I've got kind of a custom script extension. This is phenomenal. This lets me take a script, it could be PowerShell, CMD, a bat file. If it was Linux, I can have bash. It's running under the native guest OS. And it will basically funnel that script in to the OS and execute it. It's great for provisioning. I can make it go and do things, but I could also do it while it's up and running. I can at any time trigger that custom script extension to make it do something. You can see I've got anti-malware. I've got various kind of monitoring agents that hook into things like log analytics. If I go to add, you can see there's a whole bunch of other types of agents from other vendors for different types of capability. Now, in addition to that, we can see things that are delivered through the Azure agent through kind of custom extensions. I can see, hey, you can automatically shut down at certain times. Again, shut down in terms of deprovisioning, that's when I stop paying for it. If I just shut down within the guest OS, I'm still paying for it because it's still provisioned on a host. I actually want to shut it down, so I stop paying, then I just pay for the storage. I can, with a few clicks, make it go and back up to a recovery vault. I can set up replication to a region I pick. So this uses Azure Site Recovery. It puts an agent, the mobility agent, inside the guest, and now I can make this replicate to another region. I can actually go and configure things like automatic update for the operating system running inside. There's inventory. I have this nice little run command. This is a cut down version of kind of the custom script extension. This is just, I want to run a command. So I could do a custom command, and there's things to help me. Hey, I've locked myself out of my VM. I could maybe reset certain firewall, reset the RDP ports. So if I've done something silly and I've locked myself out, I can fix it. I can enable administrator accounts. So these are just using a run command extension to do things inside of that virtual machine. And again, also some of those give me insights to other pieces of information about the virtual machine. If it was Linux, I can have full serial console access and actually interact. On Windows, it's not so fancy because it's Windows. I can do things like boot diagnostics and actually get a screenshot of what is the current session 0, kind of that boot console of that virtual machine. If maybe it's stuck, it's not booting properly, I can try and kind of go and see what it's doing. There's kind of those reset, redeploy, maybe something's broke, you'll just redeploy the VM back onto the fabric. I won't lose the content. Remember, the disks are really where the state is stored. It's going to just redeploy that there's something kind of sick about the virtual machine. And I'm showing all of these things from the GUI. Ordinarily, I want to use kind of infrastructure as code. I have an ARM template. I have Terraform. And that's where I've defined all of these extensions to bring in and add capabilities to the actual virtual machine. But go and look at the extensions. They're phenomenally powerful. Might have a public IP. Hopefully not. Really, I want public IPs on load balancers, app gateways, and then have the VM as part of some kind of back-end set. That's the more secure option. It might have InfiniBand, it might have GPUs, it might have NVMe storage. It depends on the series. But it might be there depending on that series and size. Don't forget about things like availability sets, availability zones. When I create my VM, if it supports availability zones, I can pick which zone, or I can pick which availability set. If I want things close together, I want lowest latency, I can also say, hey, I want to use a proximity placement group. I mentioned that earlier. That's bringing things together, super close together in the data centers. So it's going to reduce latency from a networking hop perspective, the racks they're connected to, the switches. I'm not covering this here. Go and look at the resiliency module. I cover that in super detail there. But realize that's an important part of your design. I might have a managed identity. Now I'm going to cover managed identity when we talk about kind of security. But essentially the managed identity works by this VM. This can actually, if you think about, there's Azure AD. I can actually have an identity for this particular Azure resource. And the way this works is you can kind of think about it. Well, okay, I've got the virtual machine. Then I have Azure AD. So that identity is now stored as another type of object. It's an identity, a security principal in Azure AD. Now, processes, so if I have some process running inside that VM, only in that VM or that app service or that function, whatever construct's using it, I can say, hey, I want to authenticate as that managed identity. I don't have to do any credentials. I'm in the VM. So I can automatically get a token that represents the identity of that virtual machine. Then when I try and access some other service as that process, what I've done in advance is when I think about kind of the access, the ACLs, I gave, hey, if this is kind of VM1, so there's a managed identity here for VM1, I said, hey, VM1, you have contributor access. So now the process can take that token, use it to talk to that storage account, and is talking as VM1, and will now have contributor. I don't have to try and store credentials anywhere in my code or anywhere else. It's inherently who I am because I am VM1. So I can turn that on as part of the virtual machine. We can quickly go and say, hey, identity. I can do system managed or user assigned. If I just say on, it will then go and create that object in the Azure AD. Processes inside can then use it. And then for my resources, I can just go and give it access. So super quickly, just to kind of show an example, I think I'll just pick a storage account. It's the easiest way to do it. If I go to my access control, I want to add a role assignment. Doesn't matter what role I'm doing. But here I can say, hey, managed identities for different types of service. I don't think I have any for VMs. Oh, I do. I could just pick this one. So now any process running in Windows 10 VM I have could go and get the token, and I would have contributor rights to this storage account. Nothing they have to store, nothing they have to do. It's just inherent to that process. So that managed identity is actually super powerful and super useful. So these are all the aspects of a VM. So it's not just this thing, it's all these components. And make sure you remember there's all these components. If you delete a VM, delete the disk, delete the public IP, make sure the NICs get deleted. It's really useful to use resource groups. I have a resource group, not per VM, but per kind of service. But all of the resource groups resources for that VM would be together. It makes it a lot easier to see them. Use good naming. In my ARM template, when I create a NIC, I'd have it with a VM name -NIC1. For the managed disk, VM name -OS disk, VM name data disk 1. Make it pretty obvious from a naming what is used. Some of the naming the Azure portal does is not that great, which is why, again, it's better to do it from kind of an Azure Resource Manager template. Even PowerShell CLI is going to be better. So I have all these different aspects. Now, when I think about supported operating systems, it's Windows only. I'm kidding. So yes, obviously it supports Windows. There's an article. If I go and look at this article, it will go through all the different versions of Windows. It actually supports all the way back to Windows 2003, which seems kind of bizarre, but you can actually deploy that on Azure. Hopefully no one has 2003, but you absolutely could. For 2008 R2 and above, there's images in the Azure Marketplace with the Azure agent, everything you need. There's actually extended support for kind of 2008 R2 and beyond. It says there's no standard image for 2016. You would just use data center. The licensing is part of it. There's no functional difference between standard and data center, so you would just deploy data center. So this talks about all of the OSs I can use. It even talks about certain roles and how they're supported running actually in Azure. So that's the Windows side. And then obviously there's Linux as well. I think it's 2/3 of Azure is now running Linux workloads. When you think about things like containers, Linux. And there's a massive number of Linux distributions supported as well. So if we go and have a quick look. Now there's ones that are supported, and then there's kind of Azure enhanced versions that have not just the agent installed, but other kind of customizations for Azure. So we see these Azure tuned kernels. So these are closely working with the Microsoft team and the Linux distribution. Microsoft puts a lot of code into these, and it's really tuned to get the best possible performance out of Azure. It tends to be updated more frequently. But we can go and see here all of the ones that are supported, and it tells you whether or not the agent is just there. If there's a different package you have to go and get. So it gives you all of the details about drivers and the agent to make it work properly in Azure. So the key point is definitely not just Windows. There's a huge number of images in the Azure Marketplace, ones for just the base OS. And the things that's nice about these is that they'll release new versions with the new patches. So as, hey, the monthly patches come out, there's a new version of the image. And that versioning is super powerful because we'll talk about this later on. There are ways that some things will actually auto update a deployment when there's a new version of the image. I don't have to patch it. It's like, hey, there's a V5, and let's update everything that's deployed to V5, and then V6, and then V7. So there's a massive number in the marketplace, base OS, and also with apps installed. So it might be configuration, it might be pre-baked in the image. They're there in the marketplace. So go and take a look at what you need. I can create my own images. There's different ways to do this. I can use things like Azure Image Builder. This is Packer really behind the scenes, Windows and Linux. Take configurations, build it into an image, and you spit out your own custom image. I might use DevOps. I might have a DevOps pipeline that can go through, build an application and inject it in, spin out an image. I could create a VM in Azure, do stuff to it, and then capture it to an image. There's a bunch of different ways, but what's really nice is to use this shared image gallery. When I use the shared image gallery, it stores my image. It has versioning, so I can do a new version of the image. So that idea later where I'll talk about, hey, I can update automatically for my own images, I can have versioning via the shared image gallery. So hey, my custom image v2, it's got latest patches in, roll this thing out. The shared image gallery can be geo-replicated. So hey, I want to create VMs in 5 different regions. We'll replicate the shared image gallery to those 5 regions so it's locally available. It will automatically scale as needed to make sure it can deal with however many copies are trying to happen at any moment to actually use that image. I can share the image gallery across subscriptions, shared image gallery. I can even share it across Azure AD tenants if I have the right permissions in place. So this is super, super powerful. Definitely if I'm using my own images, use the shared image gallery. I then install my apps inside, just like anything else. It's a VM. The question is, can I install this in Azure? If it's your own custom thing, the answer is probably yes. Now, if it's a third-party app, you may need to check, do they support it in Azure? At the end of the day, it's just an OS. But check with the vendor, do they support it in Azure? Agents, hey, if today I'm using SCOM on-prem for monitoring, I can install SCOM in this. Yes, there's Azure Monitor logs, there's capabilities in Azure that might be able to replace it. But if I'm comfortable with where I am today, I don't have to. I'm using SCCM to patch things today. Sure, go ahead. Again, there might be better options. I can natively update, but SCCM has great granularity and reporting. Maybe I want to keep that. So then SCCM, I'd probably deploy distribution points or other types of element of SCCM to make it more efficient for the VMs in Azure. Hey, I want to join them to domains. Great, stick some domain controllers in Azure. Improve that performance, change the DNS of the virtual network to point to those DCs in that Azure VNet. There's nothing special about this. They're VMs. So I want to talk now about maintenance considerations. And yes, there's maintenance. And I'm focusing on the Azure maintenance, not the maintenance inside your virtual machine. Your patching of the guest OS, that's your job. That's your responsibility. That's you rebooting the VM. Again, things in Azure can help you. There's automatic patching for guest OSs. But I'm talking about the Azure Fabric. It has some maintenance it has to do. Those Hyper-V hosts that are essentially running your VMs, well, they require some maintenance as well. So I want to talk about what does that mean to your virtual machine. Now, there's various types of issues and maintenance your VM may encounter. I'm thinking about planned maintenance. And for planned maintenance, there's planned maintenance that from the VM's perspective, the VM doesn't have to get rebooted, or maybe your VM does have to get rebooted. Now, when Azure does planned maintenance, it rolls it out by update domains. So we talked before about things like availability sets. So if you remember with availability sets, let's come over here. We had the idea that, well, there's a certain facility. That facility had racks of servers. And I could kind of think about each rack was kind of a fault domain 0, fault domain 1, and fault domain 2. Now, additionally to the 3 fault domains we typically see, there's also something called update domains, which can be between 5 and 20 for Azure resources. And the way that really works is, as I deploy, not only am I spread over racks, I'm going to spread over these update domains. So it's kind of an update domain 1, update domain 2, update domain 3, update domain 4, etc. And so resources also get balanced between the update domains. If I'm using multiple availability zones, each zone can be thought of as an update domain if I just do a zone redundant, or I might have these within a zone. But you can kind of think about this is how Azure is doing its maintenance. It will never take down more than 1 update domain at a time. And it waits, I think, 30 minutes between update domains as it rolls out its updates. So what that means is if I had 5 update domains at any particular moment, 20% of my capacity, if I had 5 instances of 1/5, might be unavailable. Now, if it's that sort of maintenance, we will get told maybe you could increase the scale for that window if you kind of know it's coming. Now, what I would say is generally there is no impact. Azure's done these phenomenal changes to the OS. They can replace pieces of the kernel while it's running. Generally, there is not any impact to the virtual machines. They have a technology called VM Preserving Host Update, VMFU. And what this does is Azure doesn't patch their hosts. Instead, they inject, they replace bits of the kernel while the thing's running. But what it could actually do is it could, even if it had to do something more drastic, it would freeze the VM in memory, maybe do whatever it had to do, then unfreeze it. Typically that's 10 seconds, 30 seconds maximum. Now, also what they've started to do, and they didn't used to do this, but if you think about, well, your host, there's your host, it's running a certain, say V1, and then there's your VM. And your VM is obviously attached this local VHD for temp. If it's now going to potentially be a longer, it needs to reboot the host, what they actually now can do is, well, there's another host, and this host is already running V2. It's already been patched. Your VM doesn't require a reboot as part of whatever this update is. It doesn't impact. So what they will actually do is a live migration. If you're a VMware person, this is vMotion. It will live migrate the memory, so it's running. It will copy the storage, and then once it's kind of finished copying the storage, the ephemeral disk, and the VM, it will switch it over. A reverse ARP goes out for the software-defined networking, and now this is kind of goes away. It's running over here. There's a few seconds of freeze because it has to copy the final bits of memory, but it's super, super small. Now, it cannot do that for everything. It cannot do it for like the G series, I think the H series, I think I wrote it down, M and N. So that's not the G, H, M, and N. They're just, I think, too big. So like the NVMe, for example, and the other components like the N, the CUDA cards, it just can't live migrate that stuff. But for other series, depending on the type of maintenance that's coming, they'll actually live migrate that. Now, that's if it doesn't require a reboot of your virtual machine. What if it does require a reboot? So if it requires to reboot to your virtual machine, you'll actually get kind of a notification. So what's going to happen then is we talk about this scheduled maintenance. So the scheduled maintenance, they're going to tell you in advance. They're going to say, hey, look, in this time window, normally I think it's like 30 or 35 days time, we are going to have to reboot your virtual machine. That might be fine for you. Or you might elect to say, no, that's really not okay. I want to control when that VM reboot happens. So what you can actually do is self-service. And with self-service, what actually happens is you will pick when you want that reboot to happen of your VM. And what essentially is going to happen is you're going to lose your ephemeral storage. It's going to reboot. But if you imagine you're currently running on this V1 host, it does the same thing except there's no live migration. You'll say, hey, I want to do self-service restart now. It will shut down and then restart you on a host that's already been patched. So you have control of that kind of scheduled maintenance. Again, if you opt not to do that, maybe you don't want to lose that temporary storage. Now remember, it's ephemeral anyway, so you could lose it another time. But if you opt not to do that self-service and just restart onto a host that's already patched, within this time window they've told you about, it's going to reboot, And I think it can actually be up to like 25 minutes. Again, it's only one update domain at a time. Your service should have multiple instances, at least 3, over different fault domains. So it's not like my service goes down, I just lose a certain percentage of my capacity during that maintenance operation. Now you might wonder, well, how do I know? And again, this is super rare. These maintenances where it has to actually reboot, it is very unlikely now. They can patch the kernel and keep the thing running and just do this VM preserving host update freeze, or if supported, it can actually live migrate you. So you'll get an email. You'll get an email and well in advance to saying, hey, this is coming. There's also, so when I talked about this VM, there's something called the metadata service. So if I think about kind of my virtual machine, there's this little cloud here, and it's the metadata service. And as the VM, I can go and query this metadata service. It's a fixed IP address. I can't remember what it is top of my head, and we'll see it in a second. It's like a 168, I think. And I can find information out about me as a VM, what scheduled maintenance is coming, and it will tell me. I can also go and look at kind of the help and support. So if I jump over to the portal first, I'll show both of these. So let's close this down super quickly. So if I go to help and support, if I go to service health, I can see planned maintenance. I can also see any issues around Azure in general. And I can see there is none affecting my subscription. Now within the actual virtual machine, which is why I've got this up, so this is this special IP address. It's 169, 169.254, 169.254. That should have been easy for me to remember. It's the same for every VM, no matter what the network. It's always this 169.254, 169.254. And I can query, if we look at this query right here, this will ask, hey, are there any scheduled events? So if I run that, my response is blank. So there are no scheduled events for my virtual machine. Now I can do many other things. If I go, again, let's kind of look, I could just look for general information about my virtual machine. And what this has done is, let's make this a bit bigger. It's giving me a whole bunch of info about the VM that's hosting this particular OS instance. There we go. So I can kind of see information. This is all about the VM itself. So I can see, hey, yeah, that it's in the Azure public cloud. I can see my region. I can see the name. I can see the image I was built off of. I can see my fault domain, my update domain. This is not in an availability set, which is why they're kind of all 0. I can see lots of information, storage, tags, version information, network information. So it's giving me tons of information. Now I've got other commands here that kind of show aspects of that. For example, I've got just what cloud it's running in. I've got one here that will show me just the tags. So if I run that, I can just see the tags for this virtual machine. So this metadata service is super useful. So within the OS, yes, I could find out about the scheduled events, but I don't have any for this virtual machine. But it also lets me go and get a lot of really great information about many, many other things. So when I think about, hey, I want to know if that scheduled event is coming, I can look at the service health, and I can actually go and query it from within the VM as well. Then there's unplanned hardware maintenance. Bad things happen. Azure tries to preemptively detect when there's signs of a failure. Now, if it does detect, hey, a failure is coming, this process we talked about a second ago, this live migration, well, it will use this again if it can. If it's not that G, H, M, or N, it will actually try and live migrate it before the hardware failure. Now, if it can't live migrate it, then what happens? Well, then we get unexpected downtime. Essentially, at that point, it can't live migrate. The VM will be healed as quickly as it can. It will be reinstantiated onto another host. It's going to reboot in a crash consistent state. Obviously, most likely, depending on the failure, I've probably lost my ephemeral, my temporary storage, either contents of that temp drive. That's probably gone as well. Remember to use availability sets, availability zones. Use those kind of update domains to minimize impact. Use multiple regions in case there is some kind of regional outage. Now, what about being an only child? Ordinarily, I don't own the host. Ordinarily, my VM gets created on a host, but so do other tenants' virtual machines. They get created on the same host. Its hypervisor is completely protecting them from one another. I can't go and do something to someone else's virtual machine. But there are other people on the same physical Hyper-V host as me. Well, sometimes I don't want that. So while that's normally the case, there are options where the host is dedicated to me as a customer. So the first is to use an isolated VM. An isolated VM is there's nothing special except that essentially the VM is so big, it just takes up the entire host. So no one else can run on it with me. So if we look at the isolated VM options, here it shows the offerings. So if I create any of these virtual machines right here, no one else will be on that node with me because it doesn't fit. These VMs take up the entire host. So the easiest way to not share, create something so big no one else fits on it. Then there's dedicated host. So with dedicated hosts, I essentially buy out an entire box. And then I can fill it with VMs of different sizes that are within the series that that particular host supports. So if I look at dedicated host, this is the pricing page. Actually, it's going to look at the detail. If we scroll down on this page, so these are all the different types. You can see it's DAS v4 type 1, available RAM, number of virtual CPUs, details about the processor and the cost. So it's sort of $6 an hour, $4 an hour, depending on the size. If I scroll down, it will actually show me the types of VMs I can run. So hey, I can buy this DAS v4 type 1, or I can run all these different types of virtual machine until it's full. I can't run any series. It's linked down to a particular series of particular sizes, and I can fill up the box until I kind of hit that number. So it's still kind of on regular network. It's still just Azure, but now no one else can be on that box with me. Now, obviously, I'd want to make sure I'm filling it up or I'm kind of wasting money. But now I can be assured if there's very regulatory or compliance requirements, that box is just for me. Now, I will say something. If you use isolated VMs or dedicated host, you actually get another maintenance option. Do you remember I said before you get told maintenance is coming and I could self-service and move in advance? Well, the reason they don't let you just pick a time to do the host maintenance is because there's other customers on that host with you. Well, there aren't other customers on the host with you here. So for both of these offerings, I can actually set either do the maintenance now, I'll pick when it does the downtime, or I can pick a recurring maintenance window. I think I have to have one every 35 days, and it will just always do the maintenance in that window. So if I know Sunday afternoon, I'm good. You can always do maintenance then. I could set a maintenance window for my services and it would go ahead and do it then. So I have more control of when it will actually do the maintenance because I'm not sharing with someone else. Then there's things like Azure Stack Hub, Edge, and HCI. These run on premises. So this is, you're not sharing because this isn't really public cloud Azure anymore. These are edge devices. Azure Stack Hub is a big turnkey appliance. There's different sizes for, I think it's from 4 to 16 nodes that, again, I purchase, is hyper-converged. So there's no like separate disk. The disks are in the nodes, and then it uses software to make them resilient and replicate across the nodes. There's Azure Stack Edge, more single U units with things like FPGAs for really like cognitive services. Some of them have GPUs in them. HCI is really just my own hardware now, or from certain partners. HCI v2 is a special version that I pay for via Azure subscriptions. It's a special version of the OS I install on it. Azure Stack Hub is completely isolated. It runs on-prem. It has a local Azure portal for users and a local Azure portal for admins. Edge is managed through Azure. HCI is kind of a hybrid. HCI is really Windows Server 2019, Hyper-V, storage space is direct from the Windows Admin Center. That's why I manage it. But it also has Azure Arc built in. Azure Arc is kind of that ability to take the Azure management and bring it to things like policy and tagging and RBAC. It can deploy AKS clusters, then have data services. They're working on adding the ability to create VMs from the Azure portal to kind of the Hyper-V on that in the future. So this would be just another way to think about, hey, I want to run Azure services. And this is obviously way more than just virtual machines. HCI is VMs, but again with Arc, if I deploy AKS, then it's containers, and then it's data services via the AKS. Edge is really IoT, but it's containers and it has VMs. Azure Stack Hub is a whole set of different services. So this is about Azure consistency. So right now it's showing us all of the services that it actually supports today. So obviously virtual machines, app services, functions, AKS is coming, Service Fabric, IoT Hub is in dev, Event Hub's in dev, Key Vault, super useful, Azure Storage, Blob, Queue, Managed Disk, and Table Storage. Then it's got a SQL resource provider that lets me kind of run SQL in VMs and expose it out as PaaS and other types of capabilities. So the whole point of Azure Stack Hub is it's Azure consistent. It's not equal. It can't do everything Azure can do, but the things it does do is done in a consistent fashion. So if I needed like on premises, maybe it's close to some anchor. I've got some mainframe. I have to have it close to that. Azure Stack Hub could be a great solution for that. Edge, again, is for those kind of edge scenarios. It can show me storage from Azure. It's good for like that edge, maybe cognitive services, and send results up. HCI, I just want to take advantage, kind of some of those Azure models with my own sets of infrastructure. There are bare metal offerings. SAP HANA is a resource consuming beast. There are large instances to support this, but there's also the ability to actually deploy it directly to bare metal. So it's a special configuration in Azure just for that. I think I heart VMware. This is not me personally, but some people heart VMware. So Azure runs on Hyper-V. Organizations may need to rapidly vacate data centers. They don't have the time to retool. So the Azure VMware solution is a first-party Azure offering. It's provided in partnership actually with VMware. So they're certifying the configuration. And the idea of this is, essentially it's VMware hosts. So now my physical boxes, what gets exposed to me are, I get these boxes with lots of kind of local storage in them. So it uses vSAN to provide replicated storage kind of across. It's running ESXi as a hypervisor. It's using kind of NSX for the networking.
So now I can just run VMware virtual machines in that environment. I have to have a minimum, I think it's 3 nodes, and I can have between 3 to 16 nodes that make up a particular private cluster. But for me as the admin, I can now use vCenter. I'm using my familiar tools to actually administer this. What it's really doing behind the scenes, if I had kind of a VNet, a virtual network, I'm really kind of connecting these with ExpressRoute. It's like a special web ExpressRoute over here to connect to VNets. To maybe I'm running the vCenter in a VM in the VNet to go and manage this environment. If I had kind of my on-premises, then I could think about, well, we're used to ExpressRoute. So again, if I have my ExpressRoute here to that Microsoft backbone, I can use ExpressRoute and I'm using the ExpressRoute Global Reach. So ExpressRoute Global Reach enables me to connect things by connecting different ExpressRoutes together. So essentially I'm kind of connecting it to this. So now from here I could be running vCenter. I can also use HCX. So HCX is kind of this enterprise bulk solution. I could vMotion VM, so no downtime. From here I could kind of extend with the NSX, my network into here. I have these complete capabilities for my VMware environment. So I'm in a hurry. I need to get out my data center. I don't have time to retool. The Azure VMware solution could be a good fit. I'm getting the entire host. I use my familiar tooling. I can just go and spin up my VMware. And then maybe later on, I think about moving things to Azure Resource Manager to get all different Azure services. But through this connection, I can also get to things like Azure Storage, all the other services there. So if you heart VMware, you definitely have that option. Okay, so we understand virtual machines, and I can't believe I talked about virtual machines for 90 minutes, but virtual machine scale sets. This really builds on the idea of virtual machines, and a huge number of services use this behind the scenes. Things like AKS worker nodes. I can build those based on VM scale sets. Things like Azure Firewall built on scale sets. ExpressRoute gateways built on scale sets. Because often I need more than one instance of something. It's not, hey, there's a VM. I don't want that. The point with the cloud is I want multiple smaller instances so I can scale out and in, because I pay for it when it's running. So I have all these different instances. And yes, I could absolutely manually create them all, but I don't want to do that. I would like to be able to say, hey, there's this template, create me this number of them. And because the capacity may also vary over time, it would be nice to somehow automatically change the number we have based on that variation. So virtual machine scale sets enables me to pick a template and a configuration along with scale parameters. So what I can think about here is I have a template. So I can think, okay, so I have my image. So we often talk about the idea of this gold image. We'll kind of try and color in as gold as we can. So we have the gold image. So the image is obviously kind of our operating system. It may have apps built into it, or we could kind of push the apps as part of the overall configuration. So we have an image. And then we also have kind of a configuration. That configuration could be things like extensions. And those extensions could do things like, well, install apps via a custom script extension, other types of agents, whatever I need as part of that. I would also have things like a disk configuration. I would have a network configuration. So I have a configuration for kind of what is the OS instance. And then I also combine that with kind of my scale requirements. So I can think about a minimum number, a maximum number, a default, And then what are my scale actions? So what are my kind of scale out and scale in conditions? That could be average CPU, could be IOPS, could be it's really working off of a queue, and if the queue gets too big, i.e. they can't keep up, we'll add more of them. So I have all of this, and the net result is it's going to go and create the virtual machine. So maybe my default count was 2, maximum was 10, minimum was 1 maybe. Though I don't like the idea of 1. In fact, I'm not even going to say that. We're going to say 2 there as well. And there are other things. I can say I want to do AZ resiliency, so it spreads them over AZs, how I spread them over fault domains and update domains. But essentially it would kind of start off. It's going to create them based on all of this configuration, run scripts. If it was Windows, it could join domains, all of that stuff. I can also configure it so that, hey, the chances are if I have multiple instances, well, I need some way for things to get to it. So I could automatically add them as part of kind of a back-end set configuration of a load balancer. So as it adds and removes them, it will automatically add and remove from this load balance set. And then because of this scale, which could also be some kind of schedule, they're running kind of hot. There's lots of stuff happening. Hey, it adds a new one. Oh, things have quietened down. Okay, delete it. And it does delete it. It doesn't shut it down and leave maybe a disk behind. It deletes it. Deletes the VM, deletes the disk. All of it goes. So I'm just paying for whatever I need at any given time. And again, there's probably a managed disk. Might be multiple. I have all those configurations. So I'll be paying for the kind of disk as well. So the point of a VM scale set is I set a configuration, I set scale, and I don't have to do this auto scale. I could do manual scale. I could change the numbers when I want them. But the real beauty is, hey, let it do it for me. Let it go and change this based on what I need. As part of the configuration, I have all of these great extensions to go and do all the work I need. Again, I talked about that load balancer set. That's kind of all goodness. So let's see one of these. So if I jump over here, so I've actually got a bunch of VM scale sets, but there's really one I want to focus on. And the reason I have a bunch is because I've got 2 AKS clusters. Well, AKS clusters use VM scale sets as one of the options to work out its worker node pools. But I have this VM scale set test. And obviously, it's VMs underneath. It's just creating them for me. And what I'm going to do in here is I have an instance size. Now, VM scale sets can actually use spot instances. It has to be the entire cluster. I can't mix them. But I could actually say, hey, use spot instances for this particular cluster. I really want to try and optimize my spend. I have no idea why this is being so slow. All right, here we go. So you can see, hey, just quick things. Fault domains, 5. You can see that here. So I'm spread over 5 different fault domains. Now, regular availability sets only spreads out over up to 3 maximum. I'm not doing that here. You can see I'm actually running this Linux. Could be Linux or Windows. And you can see I've got a certain size. That's the VM size underneath. Could also see I have that option of an ephemeral OS disk. That's where it wouldn't use kind of that durable managed disk. It's just going to use it locally on the node. And so what I can see right now is I've just got one instance. I'm cheap. It's got this one instance running. And I can see the details about it, kind of the work it's been doing, properties, etc., etc. I'm going to go and look at my scaling. I've got custom auto scale. I'm not manually scaling it. I did a custom. And what we have here is if we go and look down, firstly, I've got these instance limits. I can see I've got minimum, maximum, and default.
I've then got scale conditions actually based on this. And what I've done is I'm scaling based on a metric. And I've got a scale out, I add more instances if a message count on an Azure queue is more than 5. And I'm saying increase by 1. Scale in, I delete an instance if the message count is below 2. And then I'm obviously going to decrease by 1. I could add additional rules. I can use all different metrics. I'm using my current resource. I could use a queue. I could use a service bus. I could do something else. I could measure it based on CPU. And with each of these, there's like a cooldown time. And the reason we have a cooldown time is I don't want to do a scale action and then instantly scale again. Maybe my scale action hasn't had time to actually take effect yet. So I need to give it time to cool down before I try and do another one. So let's actually see this. So right now, I've got one instance because it's monitoring this queue. There's only 2 messages. Now remember, my rule was if the queue got more than 5, it should scale up by 1. So I'm going to add some messages. Now for all of those counts, it's per instance that exists. So what that means is I've now got 6 messages. So if I look at my instances, within kind of 30 seconds, so it's even quicker, it's creating new ones. Now you'll notice it's creating 2. One of the options, and it's the default option, is actually to over provision. And what that means is, hey, doing the scale action, rather than just creating the one it needs, it's going to go ahead and say, hey, I'm going to create 2 new ones. Whichever one finishes first and is ready to go is the one I'll keep, and I'll go and delete this extra one that I was provisioning. The reason it does that is in case something fails. Maybe the creation failed and it would slow down my scale. It doesn't charge me for the extras that it is trying to do. And again, whichever the first one is, that's the one that it will actually keep. Now, I don't have to have that behavior. If the application I have doesn't respond well to my instances getting created and then deleted straight away, I can turn off that over provisioning option. So it would just create 1. It would, whatever the scale number is, that's what it would actually create. You can see here it's kind of going through, and eventually once these finish, one of them will get deleted. It will just keep whichever one is kind of finished and ready and responding first. That's the one that it will be kept, and the other one will go away. Now it has a cooldown, so it wouldn't do anything again anyway, but there's only kind of 6 messages in that queue. And my scale action is 5, but it's 5 per instance. So now there's 2 instances. I'd have to have more than 10 messages. Now you can see one of them went away. It just kind of kept the one. So I have that option. If I look at my configuration, I've got things like instance termination, notification. There's different policies. As part of the property, I'm trying to remember where that over provisioning is. It's somewhere. We'll find it as I start going through the various things. But that over provisioning, maybe it's part of the scaling, it is an option I can actually set. So I configure, does it do that over provisioning or not? And I can turn that off as part of the cluster. So now we can see I've got 2 instances. It is not going to scale again because my scale is it has to be more than 5 messages. But that 5 is per instance. Now there's 2, I would have to have more than 10 messages on the queue to make it scale again. Likewise, if it was a CPU threshold and the CPU threshold was 80%, it'd have to be an average of 80% over all of the instances before it would do that scale. So that's kind of the point of this, but you kind of saw that auto scale in action. And for fun, I don't know if it's how much fun it is, I can actually now start dequeuing these messages. So if I just delete them and we make it go now below, so we'll do it to 3. This would kind of prove a point. So if there's 2 instances, there's 3 messages, my scaling was based on less than 2. Well, that would be 4, less than 4, because there's 2 instances. So what if we come back to this later on, what we should see once kind of the cooldown instant time has gone, we should actually see one of these will actually disappear. It will actually start doing a deprovision on that. So we'll come back, we'll look at that later on. That will kind of prove its times the number of instances. So use scale sets. I mean, they're phenomenal. That's how I'm going to really optimize my Azure spend. I really want to use these things. So now some good to know things. Fault domains and zone balancing. So with an availability set, if I'm deploying it to a region that does not support availability zones, it will use 5 fault domains. And that's what we kind of saw on mine. We saw there was 5 fault domains. But I can control the spreading. So if I use availability zones and I deploy to availability zones, I can kind of set this platform fault domain count to 1. Doesn't mean it's going to do 1 fault domain. It will show it as 1 if I look, but it's basically doing a max spread. So what it will actually do is it will use as many as it actually can. So if we go and quickly look at my scaling, I can see I have things like a scale in policy. I have kind of my instance, my configurations, all of these various things, kind of that instance termination. But what I'm actually doing is, if I go back, let's some of my properties, I would actually have options around kind of this spreading. So you can see these fault domains. Now I'm deployed it at a regional level, but I can have this capability to actually say, hey, I want to do this max spread. And actually what we'll actually do is a bit of fun. We'll add a new one. Then we can kind of see some of this stuff. So when I add a new virtual machine scale set, we can see, hey, I pick the image. Again, this could be from the marketplace. If it's from the marketplace, I can actually have up to 1,000 VMs using managed disks. If it's a custom image, I can have up to 600. You can see I can use Azure Spot. Notice if it supported availability zones over here, then let's pick a region that does. I can actually pick the availability zones that kind of I want to use. I'll say I'll deploy to all 3 availability zones. I can say, hey, what type of disk do I want to use? Do I want ultra disk? I could even here, you have that option to use my ephemeral OS disk. So don't go and store it actually to long-term storage. I have my networking. Do I want to use a load balancer? And then for scaling, I can have my initial instance counts. I can have scaling policies, so minimum, maximum, scale out, scale in. We can change all of these afterwards. I have my scale in policy, which I'm going to talk about in a second. But then under kind of my management here, I can manage things around the upgrade, policy, identity of my scale set, instance termination, advanced. This is where I can have things like, hey, I want more than 100 instances. I can do my spreading algorithm. So once again, if I do my max spreading, it will just try and use as many fault domains as it possibly can. If I do fixed, then I specify kind of what that value really is. So I have all these different options around it. Let's go back to my scale set for a second. And I've still got my 2, so it's still waiting for that cooldown to kind of kick in. But eventually, because we only have 3 items on the queue, we'll actually should see some of these start to actually delete. Okay, so I have that zone balancing, and there's kind of there's a strict option around the zone balancing, or there's best efforts to spread. Best efforts, if I'm using multiple zones, it will try and make sure I'm spreading evenly over my availability zones. But something might happen, it may not be exactly spread evenly. If I do strict, things will actually fail which I probably don't want, if now there would be an inconsistency in the spreading over the availability zones. That's kind of dangerous. Over provisioning I talked about already. By default, it will actually spin up extras in case it fails, but then it will go and delete the extras. It doesn't charge me while it's doing that. Auto image update is cool. So I talked about the idea that, okay, it's based on this image. Now remember that image could come from the Azure, marketplace, where we can actually have up to 1,000 instances then, or it could be from the shared image gallery, i.e. it's ours. And I think you should check, I think it's 600 is the max when I use that with managed disks. And both of those have versions. So you can think about, hey, I deployed this and it was with V1. Well, now there's a V2 has been added. That V2 has this month's patches in it. And if I've turned on that image auto upgrade, what it will actually do is it will go through never more than 20%. So never more than 1/5 of my workloads, and it will basically replace them with a new version. Now again, these are cattle. The idea of things like virtual machine scale sets, there's really nothing unique or special about them. It's not going to go and keep its temporary drive. It will set up a new one, deleting the old one. But now, if this was kind of V1, well, it's going to kill it and deploy a new one that gets deleted with the new version of the image. And it's just going to do that for me automatically. So if I think about, hey, I need to keep my environment up to date for my VM scale set, I don't have to worry about patching anymore. So once again, if we go and look, we can see as kind of part of my operating system over here, I have this automatic OS upgrades. Now I kind of set this to off when I did it. And based on the image I use, it's not even available. But if you pick kind of the right images that have those versions, I would absolutely have this automatic OS upgrade option. And it would then go through and actually update the image for me. As soon as there's a new version, it would automatically just go and start rolling it out. I wouldn't actually have to go and do anything. It's still running. I'm still waiting for it to go and delete one of those things. So marketplace or your own, just make sure if it's your own, you have to put it in the shared image gallery. As you increase the version, it will go and roll it out. Instance repair. So here we can think about, okay, we don't really care about the VM. We care about your app. So you have your app running in here. And as part of that, your load balancer to check if it's healthy has a health probe. And the health probe is talking to the app in some way. Maybe it's a certain port, it expects a certain response. So what I can actually say is, by that health probe, or there's an application health extension, if I don't get the right response back, i.e. it's not telling me it's healthy, it will heal it. And the way it heals it is it will delete it. It will delete it, and it will redeploy. Hey, it wasn't responding. It will redeploy one in its place, run all that config, all the extensions to get the app back in, then add it back to the load balancer. For the healing, so you can think about this was kind of the image update. It would do up to 20%. For the healing, it will never do more than 5%. So it will only go through kind of one at a time, delete, redeploy to bring it healthy. So that's if the load balancer, or if I'm using it, that application health extension is not returning a positive response, then it will actually go and heal it for me. Scaling policy. So this is actually when I'm thinking about, well, how do I actually bring the things back in when I'm actually doing my scaling? So in here, I'm going to refresh it again. It's still there. If I go to my scaling, you can see I have a scale in policy. So this is saying, well, when it deletes things, how does it delete them? So by default, it's going to try and keep a good balance over the fault domains and the availability zones. So it will just fairly evenly delete to keep a good balance. Or I can say, no, delete the newest one. Or I could say, no, delete the oldest one. So I can pick how it actually goes and performs the deletions, those scale in actions, when it's actually running. And here I can, just for fun, we can kind of go and see, hey, the incident count over time. It also does write an activity log every time it does a scale operation. So we'd kind of see, it's flapping right now because I'm probably messing around. But I would kind of see various auto scale there. We can see its scale up happened. It'll say, hey, I'm initiating, and then completed. And if you actually look at it, it will show you it went from 1 in this case to 2. So it's actually a good way to go and monitor what's happening in your scale. I can go and check out the activity logs for my scale set. I actually wrote some PowerShell to go and do that for me. So I can kind of see those things in action. So we can control the scaling policy. I can do termination notification. So this is interesting that you think about, okay, they get scaled in. They just get deleted. But what if I need to do something before it gets deleted? Imagine this was a Windows VM and it was joined to the domain. Well, I need to unjoin it from the domain first to keep things clean. Maybe there's just some kind of something I want to do. So as part of my VM scale set configuration, I can actually turn on terminate notification. And I set a time, I think it's between 5 and 15 minutes. So now what happens is when it knows it's going to scale it in, the VM can actually go and query that endpoint that I talked about earlier, and it will tell me if it's waiting for a terminate notification. So here's some example code, and it's using exactly the same endpoint as I got that other data from. Essentially what I'm doing is I'm querying it and I'm asking for scheduled events. And here's an example of a scheduled event if it was going to get terminated. You can see the event type is terminate and it's scheduled. So what I would do is I would have some task actually running inside that guest that is periodically querying that metadata endpoint. And then if I see, hey, look, there's a terminate, I would go and do whatever it is I need to do to cleanly clean up, and now I'm ready for deletion. So it gives me just that option to kind of, hey, look, I see the deletes coming. And then we have instant protection. Now the point of it is, no VM is special. But in kind of the George Orwell Animal Farm, maybe some are a bit more special than others. So I can protect certain virtual machine instances that are part of the scale set. So here when I'm looking at my instances, if I actually just go and look at one, you can see there's a protection policy. So what I can do here is I could say protect from scaling. So I could still go and manually do things, or upgrades would delete it. Or I can say protect it from scale set actions completely. So here upgrades wouldn't impact it. This is protected. It would not get removed. So if I do have maybe one that's a bit more special than others, well, I can go in and give it that protection. And I know why it's not scaling. My math is poor. It's rounding it. 3 would be like 1.5, and it's rounding it up. So if I DQ one more, then it's obviously, remember it was if it was if we look at the instance conditions, because I really want you to see it scale down, my scaling condition was if it's less than 2. So there's still 2 in there, but to prove it's less than 2 each, now it really should scale down. Yes, again, it was 1.5 because there were 3, but it was rounding it up. That's why it wasn't scaling. But if we look at the instances, now I've deleted one. Now we can see it's deleted. So it was less than 2, but there's still 2. But if you divide 2 by 2, it's 1. So it's less than 2. It's now doing a scale action. So that's why it wasn't doing it. It was 1.5 each, and it was rounding it up. So poor math on my part. But now you can see it's actually deleting it. It's removing that instance, and it's gone. So it's scaled back down. And again, if we looked at kind of the scaling and the run history, we can see it's kind of bouncing up and down. And we would even see a new activity log scale down just happened to really show we were there. So super, super powerful. Definitely want to use auto scaling. It's going to optimize our spend. Make sure you pick the right scale action. It's no good saying, hey, I'm going to auto scale on CPU if it's IOPS intensive, or it's memory intensive, or it's doing something kind of queue. I have to make sure I understand the workload to make sure I pick the right scale action that will actually change my instances based on the work it's doing. So I hope this was useful. As always, this was bigger than I anticipated it to be, but please go and ask in the comments below. And once again, there's a lot of work to create these, so really appreciate it if you could like, subscribe, and just share this with people you know. But until next time, stay safe, take care.